We're going to start looking at the polymers, and when we're looking at the polymers, we're actually drawing on the chemistry that we've done in the last couple of units. So we're looking at the carboxylic acids and esters, but also the amides, which is the reaction between a carboxylic acid and an amine, which is the last pack that we did. Obviously, it sounds quite complicated, and the best way to do it really is to go to a little bit at a time. So this type of polymerization is very different from what we did when we did the alkenes, because this one's called condensation polymerization. And the reason for that is when this polymerization takes place, we lose or eliminate a small molecule, usually water, which is where condensation comes from. But there are other molecules that can be eliminated, for example, HCl. There's two types of condensation polymerization that you need to know. One of them is the polyester, and the other one is the polyamide. And I'm going to start with the polyester. The polyester is basically where the ester becomes the link that joins the molecules together. Okay, so it'll be easier for me to probably show you what's on here. So if I've got a molecule, and we'll call it RCOOH, and I react that with an alcohol, so this is all the stuff that we did in one of the earlier packs, and I'll just put an R on there as well. Hopefully you remember that we always cut between the carbonyl and the OH, and we take the hydrogen off the alcohol. There's the water that is eliminated during this reaction. Okay, now obviously this is just joining two molecules together, but it's we can make this a long molecule or a polymer if I was to put another carboxylic acid at the end of this molecule, and obviously goes to do an OH on the end of that molecule there, and then obviously down here I'd have another alcohol that will go on and on and on. And then when we kind of continue with this, the OH comes off the other end of the molecule, the hydrogen comes off there, and then if I go over to the other alcohol, the hydrogen would come off here, and an OH would come off a neighbouring carboxylic acid. So what we've got here is the first way that we can make a polyester, because a polyester is where we make an ester linkage to join many molecules together. So if I get rid of this here, so there's the water that has been given out, and then join these together. Okay, and if I do the same over here, I've just managed to squeeze another link in there. Join that to that O there. I hope you can see that what we've got is an ester. So we call this a polyester. Okay, so I'll go back to the notes and we can have a little think about that one. So here's probably a neater way of looking at it. So I've got two types of monomers in here. I've got a diol, which is here, and I've got a dicarboxylic acid. And what happens is the hydrogen comes off the alcohol, the OH comes off the carboxylic acid, same at the other end, same at the other end of here, and that goes on and on and on and on and on. And whatever this group is here and here ends up in the repeat unit here and here. Okay, so I'm going to go back to the screen, so I just want to give you an idea of how these kind of link together. So I often think of these as kind of train trucks, if you like, where we have a dicarboxylic acid, which way to think about that, it's got a loop on either end of the carriage. That's the kind of C double bond O OH. And then we have another carriage over here with hooks on either end, which is your diol. And of course, that's your HO. And of course, when they join together, they join with the hook and the hoop joining here, and so on and so on. So what you end up with is a repeat unit of a dicarboxylic acid and a diol that make one long repeat unit, which is what we've got here. Okay, there's a couple of examples of these. So pterylene is an example of this, which is the reaction between ethane 1,2-diol. And there we go, look, there's the water being eliminated. We'd have the same off there and the same here. Remember cutting between the carbonyl and the OH on the carboxylic acid, which gives you this really long repeat unit here. And there's the water that has been eliminated. Here is your ester linkage group, and the bit that is here is now there, and the bit that is here is now here. So these are the two different carriages, if you like, on the train track. So we tend to get this one very, very long repeat unit. Now, if you think about it, there is another way that these kind of train tracks can be linked together. Let me just clear some of this out of the way so I can show you an alternative way that we can do this. So it's not unreasonable to think that if we were trying to join our trains together, that you could have a hoop at one end and a hook at the other. And over here you would have a hook at one end and a hoop at the other. And of course what we were using there was, this is the alcohol, which is the hook, and this is the dicarboxylic acid, which is the hoop. So if you get a molecule that has both an alcohol and, not a dicarboxylic acid, sorry, a carboxylic acid group, you have a single monomer which will join to many other of the same monomer, okay? So there's basically two ways of doing this. There's this way up here, which is where you have a dicarboxylic acid and a diol. That's two monomers giving you one long repeat unit. Or, which we'll have a look at in more detail in a minute, we could have a hydroxy, that's the alcohol, carboxylic acid, which would give you one monomer because this monomer here is identical to that monomer there. And they would join again at the hoop and the hook at the front of one molecule and the back end of another molecule. So let's go and have a look at those. So some questions for you to have a go at there. So here's where we have the one monomer, and we call these the hydroxy carboxylic acids because we've got the carboxylic acid OH here, which is going to come off, and we've got the OH, the alcohol, at the back of it there. So if you think about it, that's the hook, there's the hoop in terms of the carriage, and the carriage gives us this. Now this gives us a smaller repeat unit, and the reason it's smaller is because there's only one monomer being used, whereas in the previous one there's two monomers being used. In terms of the reaction that's occurring, it's identical to your esterification reaction, just like before. We cut where the carbonyl and the OH, we cut the hydrogen off the carboxylic acid, and we go again there, and we go again here. Okay, so our repeat unit would be this twice, but the repeat unit is the single repeating structure within the molecule. So we just simplify as one of them with the hook at one end kind of taken off there, and the hoop at one end and the hook at the other end taken off, which gives us this, which is our repeat unit. It is still a condensation reaction because we're still eliminating water. Okay, some examples of that actually come from nature. So polylactic acid. Lactic acid is the biology name for this one here. So this would be, if we were to name it, one, not working. One, two, three. Over here is my hydroxy. So if we were to give it its chemistry name, it would be 2-hydroxy propanoic acid. Okay, in terms of the reaction that's happening here, it's exactly the same as what we did when we were doing the carboxylic acid. So the OH comes off here, hydrogen comes off there, OH comes off here, hydrogen comes off there, and you can see here I've got 1, 2, 3 repeat units, and there is my linkage there, which is my ester, which is why we called it a polyester. Okay.